So the first thing, let's go ahead and do this. So this is my way of solving it. Again, there are many ways of solving it as long as you are underneath the time limits and the memory limits. It doesn't really matter. Of course, some will be faster, but that's fine. So the first thing that we want to kind of keep in mind is we are making a total. So let's go ahead and set up a variable called total, and we can make that equal to 0. And then, so there are 3. Now, this is a really cool one because all of the point values go up consecutively. So what we can do is we can just set up a for loop. We can say for I in range. So we're starting at 1 point and we're ending at 3. So that means that our last one should be 4 here. And now we can just literally do total equals int times input. So we're going to grab how many treats. And now it says that it's going to be in order, right? So small, medium, large. So now we can just multiply this by I. And then at the very end, we can go ahead and just print total. So now, what will happen here is that at first the total is 0, right? And then after, for every type of treat, right, because it goes up 1, 2, 3, we're just going to create a for loop here. And then we're going to grab the number of treats. And then we can multiply that by the current treat type that it's currently on. And at the very end, we just print it out, and this should be our solution. So let's go ahead and submit this. Oh, shoot, because we didn't actually say happy or sad. All right, so now what we can say is we can say, so if it's happy, it'll be happy if, so this is going to be called an inline if. Oh, it's a ternary conditional operator. All right, that's your actual name. But we can go ahead and just make an if statement inline. So this will be to determine a value. So we're going to say, we're going to print, so I'm going to make an example here of creating a variable, all right? So so this will be, so the first thing we're going to type in is what we want the variable to be if the condition is true, okay? So we want output to be true, to be equal to happy if total is greater than or equal to 10. Else, so if it's not greater than or equal to 10, we want it to be equal to sad. So does that make sense to everyone? It's a relatively simple syntax, and it's actually extremely useful because so if you wanted to make an actual if statement, it'd be this. Say output equals happy, else. So you see, it really saves you a lot of space, and it's just all in one line. It's still relatively easy to read, right? So you want to say output equals happy if total is greater than or equal to 10, else sad. So it even kind of flows in English. So this is extremely useful. A way that you can actually prevent this from happening, because remember that every single time you submit, you are actually incurring and you get it wrong, you're actually incurring a 20-minute time penalty. So that means that if someone else then solves every single question, but they got it right, they can win the contest based on time. So we can go ahead and just test. We should always test our program. We get sad, and we see that that is the correct output. And if we have 3, 2, 1, it should equal happy. And it's not equal to happy. Oh, we had a plus equals this because it is a cumulative thing. So now this should be sad, and then after this should be happy. Whoops, and I fat fingered that. And they should be happy. All right, so now we know it's working for the test cases. Another good thing, especially for more complex problems, would be to actually make up your own tests and see if you're getting what you're expected. So in this case, it's a relatively simple question, so we don't need to worry about that. And now if we submit this. All right, so now as you can see, we got it correct. And now look, so for example, if we get a wrong answer, what we can do is we can click on this submission, and it'll actually give us a lot of information about our submission. So first of all, we can see that so compilation, there's no compiling in Python, so you shouldn't worry about that. But now we can see the run. So first it's going to run on the sample data. So this is going to be the data that is given to you. So in this case, this will be sample input 1. It'll try it out. And it'll actually tell you only the sample input, by the way, only the sample. So even if both of these are correct, you can still get a wrong answer. All right. So please keep that in mind. I have a lot of people asking, oh, I passed both of these and they were both correct. Why did I still get a wrong answer? Well, that's because some of our hidden secret test cases may have different, can be designed to kind of stress your program, and they may be wrong. And that's what actually matters. So if at least one of the test cases returns wrong, your whole solution is wrong. All right, so as you can see here, it says string tokens mismatch. So the judge was looking for sad, but we gave it 0. So obviously that would mean that it is incorrect. Okay, so now a few other things that you might get is run error. So that means that your program crashed. Time limit, which means it took way too long. And then after, yeah, that should be it. Once you do C++, you may also get compile errors. And you actually might get that as well. You will also get that with Python. It'll say if you have invalid syntax, it'll also be a compiler error. So, yeah. Also, just keep in mind here, we have a time limit right here. So we'll be kind of going into time limits and how we can kind of, we can plan for those using Python. But for now, you should be okay as long as you're not completely bashing the question. And then so the first thing, let's go ahead and just get input. So we'll say paint drops is going to equal this. And now we want to get all of the paint values. So the best way to store this would be probably in a list. So let's go ahead and do that. Let's go and say, let's say XA equals that. And then after Y array equals that. So next we're going to go ahead and loop through. So here's another thing we can do here is we can go ahead and actually use something called map. So let's say X comma Y equals, and we're going to use this map function. We're going to say we want, so these two things are going to be integers, right? So we're going to make them integers. And then after, this is going to be our array, or sorry, our list, right? So our list of of elements we want to map onto these two variables is going to be input, and we're going to split it by the comma. All right, so this is extremely useful, especially when you're getting X and Y coordinates. That way you don't need to do, okay, input dot split R, right? And then after you gotta int both of them. You gotta int, at 0, and then you also have to int at 1, right? This is a simpler method, and it's a lot more straightforward. So make sure you remember this. And now we're gonna go ahead and just say xa.append X and ya.append Y. So this will make it so that the first thing inside dot split is going to be mapped to X, and the second thing Y, and if you could have a whole bunch of these, and it'll each map it to the corresponding index. Oh, sorry, not R. So for example, let's say we have a list of like we have 1, 2, and 3. Okay. So what map does is, what you can do here is you can say, okay, well, let's say these are all strings, right? So this is very common if you input.split, right? You can say, okay, well, I'm going to give this variable. So if I want this first element to become the variable X, the second one variable Y, and variable Z, what I'll do is I'll say X, comma, Y, comma, Z equals, and now this map, I'm going to give it a function that I want to be applied to all of them. So for all of these, I want the function int, right? I want them to be turned into an integer. So I'm going to say int. So you don't need any brackets or anything, right? It's just literally the name of the function. And then after you give it this array. So let's just call this L. So now what it'll do is it'll go through every single one of these elements. It'll apply the function int to it, and then it'll assign the value of each corresponding variable to the return value of that function. Yeah, so this is kind of how we're going to be learning a lot of things. Is we're going to just be I'm going to have these questions, and I'm going to try to incorporate some of these little tips and tricks into it. So we might not necessarily have a lesson, but that doesn't mean that I'm not going to be introducing new things. It's just that sometimes it's super weird. Like if I were to teach like map, and then after I teach, the ternary operators and stuff, it's just kind of weird to teach in a lesson. So I figured that the best way to just kind of get these little random tidbits is to go through a contest. Anyway, so now we have this. So what can we do? So now we have these lists. So how can we get the bottommost and topmost corner? So what we can do here is we can actually sort this. So if we sort these two lists, we can find the lowest x and y values, which will be the bottom. So the reason that is because if we go back to our paint program here, we can see that the bottom starts at 0, 0. So that means that whatever is closest to the bottom is going to have the lowest x and lowest y value. And conversely, that's also true. At the very top, it's going to be 100, 100, right? So that would make it so that whatever point is closer to here must have the highest x and y value. Let's go ahead and do this now. So we can say it is just asking us for the points. So let's go ahead and print this. And now we're going to be using something called string formatting. So what this will allow us to do is actually quickly replace values inside a string. So I'm going to be doing the old method. There's a newer method, but I just found the older method to be a little more, well, I just kind of used it more. But I'll show you both. So the old method is using percent signs. So I'm going to have %i. So that means I want to replace this %i with an integer, and I want %i again, right? Because these are going to be the coordinates. And now I'm just going to go ahead and put another % outside of the string, make a bracket here, and then for the first one, I want it to be the lowest. So this will be xa at 0, -1. And then after ya at 0, -1, right? Because we want it to go one outside, so it actually goes around. And then we'll just copy this again. And now we'll do it for the topmost. So this will be xa at -1, which is going to be the last one in the thing, which will mean, because we sorted it in ascending order, the last one will be the biggest one. And then ya at -1 + 1. Okay, so this is how you do it with the older version of string formatting. The newer one is a little more easier to read, I guess. You use these curly braces. So wherever you put this pair of curly braces is where you want to replace it with something. And then you just say .format, and then you just do the exact same thing. All right, so you can see this one's a little easier to read, and it's not required that you put something in here. You can just put curly braces. All right, so I would remember one of these two string formatting methods just so it's easier instead of you having to say like, oh, print, and I'm going to have to strxa, at 0. Because at Python, remember, in Python, you can't actually add these values together easily. You need to turn everything to a string, then you got to say that, right? It's super long. So I would learn one of these methods to make it easier. We'll just go with the older method for now.
Could you explain the -1 and +1 thing for the x and y?
Oh yeah, definitely. Okay, so in the question it tells us that points on the frame are not considered inside the frame. So that means that if we have a frame that's going to run through the point, it won't count. So we need to go one. So for example, at the bottom, right? If we want to go one out, we need to subtract 1 on both sides. And then for the top one, we want to go 1 out so that it goes around and not on top of it. Does that make sense?
Oh, okay. Yeah, I see.
Yeah.
Thank you.
Yeah, no problem. All right, so we have just our input. So this is going to be, I'm going to just call it our haystack. So this is our, what we're looking for stuff in. And then we'll say our seed. Oh, forgot about that. All right, so you guys should be able to see it now. Cool. All right, yeah, I forgot to share my screen. Okay, so we're just gonna set up input right now, and we'll just call this beginning thing, I guess, a seed. All right, and then we're gonna store all of these. So we're gonna create a list called needles to have all the needles that we're looking for inside the haystack. All right, and now we need to actually generate all of the needles. So to do that, we know that we need to shift the letters essentially to make a whole rotation. So that means that we want to, so that means that there will be the same number of cyclic shifts as there are letters, right? Because as we move it, it'll be 1. And then by the time we reach the end, it'll be the same one as the beginning. Okay, so that means that we can shift it up to the length of the string. So we can say for I in range len of the seed. So now we can just say needles dot add seed. Okay, and now to kind of shift them around, we can just say seed equals seed from 1 all the way to the end plus seed at 0. And then after, that should be good. So now if we just run this so far, we should get all of these cyclic shifts. Now, another way you could do this is to generate them as you're checking. That also works. But in this case, I just want to kind of break it up a little more. So we're going to generate them first. Oh, sorry, not add, dot append. Add its first sets. And then A, B, C, D, E. So now if we go ahead and print out our needles, we can see that we have all of the variations here. Okay, so next what we're going to do is we are going to loop through every single needle and check if it's in the haystack. So to do that, we're just going to go ahead and say for needle in needles. So we're going to be iterating through every single element of this list. We're going to say, actually, let's also have a variable named found, so we can keep track of whether it's been found or not. That's going to be default to false. We're going to say if needle in haystack, we can say found equals true, and we can break out of the loop. So this is a really cool thing about Python is that we actually have this in operator. So what this will do is, so it'll be able to tell you whether a substring is inside a string, and it'll also tell you with lists whether an element is inside a list. So for example, if I have a list like this, if I have a list called ABC, so I can say, no, I have a list of numbers, right? I can say 1 in 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5. It'll say, yes, 1 is in this. But if I say 1 is in 2, 3, 4, 5, it'll say false, all right? Now, same thing for strings, because strings are actually very similar to how lists work. So we can say in hello, A in hello to give us false, but we can say A in hello and it'll be true. Okay? So you could also use .find. That's also a perfectly acceptable way. But in this case, we're going to make it a little more Python-y by doing that. Okay, so if we break out of the loop, we can say we're going to print, we're going to use our ternary operator again. So we can say yes if found, else no. So this is another thing that we can see here is that if we are comparing a Boolean, we don't need to say if found equals true, right? The whole thing that the if statement is looking for is a Boolean. So found equals true returns a Boolean. So if we already have a Boolean, we don't need to make any operation or we don't need to compare it against anything. We can directly put the Boolean in. Okay, and then we should get the correct answer now. So this will say yes. And then this one should say ABA, which should be no. But now, as we can see, it passed. So again, we now know that we can search for substrings using in. And yeah, that's the basic thing. All right, so what we could have done here is we can just say this. We could have said this. We could have just pasted this right in here. And that would have worked as well. Okay, and that's what some of you guys did as well. So yeah. A lot of you guys are running against a time limit, and I'm going to explain why that's happening. So if you guys don't mind, I'm going to keep you guys a little later today. What we can see here is we obviously probably don't want to completely model this, right? We don't want to like do every single step. So we're going to look for some patterns. So for sample input 1, it says the one person on day 0 with the disease infects 5 people on day 1, on 25 people and 125. So if we look at this pattern, what do we see here? Now, there are even more efficient ways to solving it, but the way that we're going to be doing is just going to be slightly optimized. It won't, right? There are other ways that we can find this mathematically, but we're just going to kind of go for the semi-math, semi-problem solving method. So what is special about these given the information we have? Yeah, so these are powers of 5. So as we can see, 5 to the power of 0 is 1. 5 to the power of 5 to the power of 1 is 5. 5 to the power of 3 is 25, and so on and so forth. So we can kind of take advantage of this. Now, yeah, this is also a geometric sequence, so we can just use the formula to find the sum of a geometric sequence. However, we actually have a little more leeway here that we can actually just manually add them up together. All right, so the first thing is we're going to get our values. So the first number here is going to be P. And then after Pn, which is the number of people who have the disease. And then after R, which is the number of people who get spread by each person. So now let's just do what we can do for now. So look and say while, I just have a while true loop here. We're going to say if, and we're going to also have a days. So let's call it D. Start at 0. We're going to say if. So let's also have a total equals 0. So we're going to say if total is greater than, and we're desiring P people to be infected, which sounds kind of morbid. We're going to go ahead and just say, okay, so we're done. So we can go ahead and print D. Okay. Next, what we can do here is we're actually going to start adding these up now. So to get the power, so we're going to first work with just one person having the disease at first. So this is going to be easy. This is going to be total plus equals. And we're going to say each person infects 5 people, right? R. And we're going to raise that. So that's to the power of is 2 stars to the power of R. Sorry, to the power of day, right? So now we can just say day plus equals 1. And then after, we should be good. So let's go. This isn't the full solution yet. So this is a really great way because, so on our judge, we just have either you get it or not. But on the CCC, you can actually get partial points. So by building up your solution one by one, you'll actually be able to get partial points so that, you know, in the case that you decide that it's not worth it anymore and you're running out of time, you can submit your solution and you can get partial points. So that's why it's always good, unless you have a very quick way of solving all the possible parts of the problem, you should solve it step by step so that at any time, if you do quit, you can still submit it, it'll still work, and you'll get partial points. So for now, let's just do this. And this should work for sample input 1. Okay, and as you can see here, I forgot to break. So let's break this loop. And now we should catch a mistake here. So we can see here that, we're printing D twice. We can see here that we're actually outputting one more day than is desired. And the reason for this is because we are actually having them spread the disease on the same day. So that's incorrect. They actually spread it on the next day, right? So what we can do is we can just subtract 1 here, which should all be good. So we can say 750, 1 and 5. This will give us 4. Now let's say that there are 2 people. Now what would this look like? So let's just imagine that this is going to be a tree, right? So instead of spreading to 5, let's just spread it by 2. So first we're going to have this, right? And then we're going to have this. And we're going to have this. Right? So that's pretty self-explanatory. Now, if we have 2 people, that means that we'll just have double the trees, right? Right? If we have 3 people, we'll just triple the number of trees, right? So what we can do here is we can say r to the power of d, and then let's multiply that by the number of people. So the number of people here is going to be designated by n. So now this should take into account people. So right, they're spreading it simultaneously, and each person is going to cause their own tree. Does that make sense to everyone? Now we have this problem solved, but let's go ahead and submit this. We're going to come up with a nasty little surprise here. All right, so this is something that you guys would have seen, right? Time limit. So you guys ran out of time. Why is that? Well, the reason for that is that Python, because it is no, the solution is correct. Okay, you will get the right amount. You will get the answer, right? But it is not the solution we're looking for. And the reason for that is because Python is actually a bit on the slow side. So whenever we're programming, so far we haven't really done anything too complex. So whenever we enter a value, it goes by pretty quickly, right? We enter it and usually we get it immediately. However, especially with Python, because it's interpreted, it's a bit slower. It can only do around 1 million operations per second. So that means that if we want to add something, or we want to, like, if we're adding something over 1 million times a second, it'll take more than a second. Does that make sense? So this is going to lead us into efficiency, which we're going to talk about next week as well. And that's why it's a little hardest to solve contest problems in Python, because sometimes you'll just run against that hard limit of around 1 million operations per second. So you may be wondering, okay, when is that going to happen? Well, it's not going to happen. This is probably going to happen with a lower exponent, right? So something like 2, but it's not going to happen for 2. What will happen, because if we have 2, right, let's just try that. If we have 1 million people we want to infect, and we're starting with 1 person, right? We want to drag this out as much as possible. 2, it's still quite good, right? Because we're raising it to the power of 2. That's a gigantic improvement. However, let's see if we are only spreading it 1 person at a time. Because look, this is 10 million. So if we're spreading it 1 person at a time, that means that we'll have to go through the loop 10 million times. 10 million times before we're going to get to 10 million, right? So let's try that. And as you can see here, we ran out of time. So we just wait for a bit. Right. So do you guys get that? So that's why a lot of you guys were getting time limits, because Python can only do so many operations per second. And you really need to be conscious about that, especially as you go into the CCC, where you may have a correct way of doing it, but it also needs to be incredibly efficient. Well, not incredibly, it just needs to be slightly efficient. So this is the only kind of edge case here. If we look, right, if a power of 2 works, obviously the bigger powers will also work. So we can just focus on handling this power of 1 case. So what we can say is we can say if the number of people who are infected equals 1, let's come up with a mathematical formula to be able to just immediately solve for it. And well, if you just kind of reason it out a bit, it'll be this. So you'll have the number of people desired, and we're going to divide that by the number of people who start off the infection. Okay, so because we have this many people, every day we're going to be infecting people, and then after we're going to divide that by the number of people who are infecting, like how many people were moving simultaneously. If that makes sense to you. Right, so we're going to divide the population equally among the people who are able to infect people, and then every person is going to be infecting it at a rate of 1. So that means that we can just divide. All right, so now to prevent us from going into that loop, we're just going to say else. So now what we get here is if we have 10 million, we'll get an immediate answer. All right, and same thing here. We can just kind of, so this is going to be straight. If we have like 500,000 or 5 million, sorry, we have 2 people who infected, right? 2.5 million. All right. So that is something to start to be conscious about now is how many operations are we doing? And we're going to go into next week how we can actually kind of describe that and have a sense of what we're doing so that we can better inform ourselves of whether a solution is going to go over the time limit. Because again, right, if you get something wrong, you usually get a time penalty, which means that that'll put you at a disadvantage. So let's go ahead and submit this one now. All right, so see, now we are correct. All right, so this is just to keep in mind that whenever you are using time limits, when you're hitting against a time limit, you need to find a way to reduce the amount of operations that your program is doing. Whether that be, using a more efficient method or just changing your algorithm. So anyway, thank you guys for coming out this week, and I hope you guys have a great week, and I hope to see you next week.